Those sensors that live in your smartphone or smart device allow those devices to know a lot more about you than you might think. And those smart devices get smarter every day with each software update. And that's thanks to machine learning. It's now easier than ever to design a low power, low cost smart device with a microcontroller capable of running pre-trained artificial neural networks like models trained in Google's TensorFlow Lite, or a wireless module that enables cloud-based prediction. The Arduino Nano BLE Sense and the STM32L4 IoT node are two development boards that make it super easy to get started. The smart devices that you use every day are most likely designed in Altium Designer, which is the world's most widely used printed circuit board design solution and the sponsor of this video. So be sure to check out the link in the description to support this channel and to get your free trial license of Altium. Hi, my name is Roman Kozak, CTO and co-founder of Verity. At Verity, we design hardware and software for agriculture. Today, we'll be looking how machine learning has enabled devices like the Apple Watch to know if you're running or walking and to know about your golf swing and swim stroke, and how microphones are being used on microcontrollers for very accurate speech recognition, also in the biomedical field to monitor breathing in patients, as well as to triangulate gunshots. We'll also learn how GPS data and location data is being used to build profiles on users about their preferences, like restaurants that they like to go to, places of work, their commutes, etc. The conventional sensor system consists of a sensor where a threshold limit is triggered for an application outcome. So Google Maps knows when you've arrived home based on your latitude and longitude falling within a certain radius of your home address. And your smartphone is able to figure out if it should rotate the screen based on the sensory information that's coming out of the accelerometer and gyroscope, so the inertial unit. But advancements in machine learning have enabled your smartphone to collect, analyze, and interpret an unprecedented amount of sensory information. So your smartphone is now able to figure out when you're on your commute home or where you've parked, and it's able to understand if you are dancing, running, or walking. The threshold limit in a conventional sensing system is replaced with a highly sophisticated smart model created with ML algorithms. The algorithms are based on mathematical and statistical methods that are implemented to analyze, process, and extract crucial information from large and complex data sets. Rather than a single value threshold, temporal data can now be fed into the model and it can run on your microcontroller. And there are tools out there like TensorFlow Lite that allow you to train, create, and export these very lightweight models that run on microcontrollers. There are two types of smart models that are created for smart sensor systems, which are dictated by the sensor technology and the application requirements. The models fall under two main categories, either those trained to solve classification-based problems or those trained to solve regression-based problems. A regression-based smart model implements a predictive ML algorithm that correlates past sensor data with future sensor data, such as future blood glucose levels based on past blood glucose levels. Whereas a classification-based smart model implements a categorizing ML algorithm that identifies and separates chunks of sensory information into discrete classes like running, walking, and sitting. The strength of machine learning algorithms lie in its ability to learn and automate the extraction of patterns and features from a given set of data, which typically has relied on domain experts to do so manually. Now let's jump into Altium Designer to take a look at 3 incredibly common and simple sensors that have become a lot more capable with the onset of machine learning. Okay, here we are in Altium Designer. It's the world's most widely used printed circuit board design solution. So if you're looking to design a smart device with sensors, this is definitely the place to go. So you'd first want to start by searching for whatever sensor you want. So for example, if you were interested in a microphone, you might type that in here. So let's see what pops up. Here we can see some of the microphones that we could consider using in our hardware product. We're able to see what it looks like with this picture here, and the suppliers as well, like DigiKey, Newark, and here we can see that DigiKey has 30,000 in stock for a price of $2.34 each. Here we can see the schematic symbol, the 3D model that will go on our printed circuit board, as well as data sheets here if we want to take a look at further information about this device. But if I wanted to right away place this device and use it in my design, I could just go here and click acquire or download, and then use it right away. And you can see here that since this bar is green here, Altium also has analyzed this part and has let me know that this part is suitable for volume production. So that's good to know. It works with IHS Marketplace to determine that. So I could simply go like this, click acquire, and then it'd be added to my part library. But I've already gone ahead and added a microphone, a GPS module, as well as a inertial unit here, just so we could take a look at quickly. So here's the MEMS microphone. I can see that there are 305 of them in stock, and it's nice and tiny. And yeah, so this microphone can be used in my hardware product for voice recognition, triangulation. I know the Amazon Alexa uses that to triangulate where users are in the room. I could use it in a security device for detecting if glass is breaking, or in my self-driving vehicle technology to figure out if there is a nearby emergency siren, or if I'm creating a biomedical device, I can use it to figure out breathing sounds and for monitoring breathing sounds in apnea patients, or monitoring chest sounds after cardiac surgery, or for example, monitoring the sound of drilling in surgery, or even drilling and mining. All of those could produce quite useful solutions in a smart device. So next I'll jump over to the inertial module, which is comprised of a 3D gyroscope, 3D magnetometer, and 3D accelerometer. Here I can see it's made by ST Microelectronics, and this is quite a common part. It's quite popular. It's sold out right now, probably due to the chip shortage, but Altium has analyzed its manufacturer lifecycle and determined it is suitable for volume production. So that means that this part is expected to be manufactured in large quantities for the next many years. So it would be suitable to implement in a new design. And this accelerometer, gyroscope, and magnetometer can be integrated into your smart device to do human activity recognition, such as running, walking. I actually just bought these smart goggles by a company called Form, and they can detect how many laps you've done in the pool, your stroke count, and so many other things. I just think that's so cool. And it's almost certain on the inside of those goggles, they have one of these units here running some type of classification-based smart model. They can also be used for like vibration detectants. So for, analyzing things in civil engineering, or maybe things like predictive maintenance for machines. So when a machine starts to fail, faults start to develop, the system dynamics change, which result in different vibration patterns, and those could be observed with this inertial motion unit. So it adds some pretty cool sensing abilities to your project. Finally, we'll take a look at the GPS, which is, an incredibly common device. And this one here is manufactured by U-Blocks, which is a very popular GPS manufacturer. And this will allow you to understand the location, the speed, the direction of your smart device. And it can be used for many different things, such as pinpointing the location of a sensor, or if it's a sensor that's attached to a vehicle or a human, it can allow you to build a profile on that vehicle or human to understand how that vehicle or how that person is using your device, where they're going, etc. So another really excellent sensor to use. This video was made possible thanks to Altium's generous and enthusiastic support. If you're a beginner looking to design your first printed circuit board, an engineering student, or a professional using a different CAD package, Altium makes it simple to learn and to switch to. And if you haven't used Altium in a couple years, come check out their new redesign, their integration with CAD packages like SolidWorks, and their new web collaboration tool, Altium 360. Thanks so much for watching, and let me know what you think by leaving a comment down below.